Hi everyone, and welcome to this new tutorial. It has been a while. I've been doing stuff on Copper, so we have a lot to catch up on. And there are like three things I'd like to kind of showcase you about what's new in Copper and what are the new things you can do with it. Overall, the project's going to be, this tutorial is going to be about extending our flight controller. So we did develop in Rust embedded a flight controller for quadcopters like this one. And so that's kind of like exciting, because suddenly you can add to what is a working flight controller. You see it here, like doing like a very sketchy power loop. So this flight controller is a working flight controller for, let's say, FPV, but it is based on Copper, and Copper is a robotic framework, right? It's a little bit like Rust. You can actually have components, and you can actually combine components and so on. And that's exactly what I want to show you here, right? With Copper, how to, starting from this project, add, let's say, a new sensor. So for this sensor, we'll use a dual sensor that does both a 1-point LiDAR, basically measuring distance, and also optical flow. Basically, it's inside this device, there is something that is close to what is like a video compressor, and with blocks and differences with blocks within the video, it can actually kind of compute what is the flow of the image, right? And you have then like an X and Y kind of vector in the direction of the image is flowing. So that's quite kind of exciting. That allows like those cool features where you see those drones that are actually hovering on top of like a fixed point. But you can imagine also, because like indoor, you'll have like a very precise, at least differential positioning. So you can do tricks and so on indoor instead of outdoor like today. So let's get started. First, I need to show you a little bit our flight controller. Our flight controller, if you look at the root of the project, it is in the Git Copper repository in examples flight controller. So you have a main config, right? And that main config, if you do just, which is like a command you can install to interpret those just files that are just like, if you look at them, they are like kind of like shortcuts, right? And if you do just Debugger, that will show you, first we'll compile, and that will show you actually the shape of this project. So yeah, you see basically the architecture of this flight controller, right? Where you have like a radio control, right? Like with like an output, so a reception for the project. You can follow the thing. You have a mapper that basically gives like dispatch that to a bunch of like various tasks, like to say if they are like, for example, if you are like armed or not, and so on. You have here like an IMU that is actually going to an IMU calibration that happens at the beginning, that goes to an AHRS, basically showing the current position of the aircraft. And you have an attitude that is basically a controller that tries to match the attitude that you order it to go into, going to a rate that is more like when you are in acro mode, for example, you can use the rate straight to actually turn around, do loops and so on. And that goes into like mixers, one mixer per motor, and that goes to D-Shot, which is basically the protocol for those motors, right? So yeah, that's basically your big DAG, and toward there it's like some UI, like you have some activity LED you can show, and there this is VTX. This is basically the goggles, right? You can see that's why I display this little cat on the inside the goggles. So yeah, this is our little project, and what we want to do is to add that flow and 1-point LiDAR feature. So For this, first we need to edit the config. And you see what we saw, right? Like in that big architecture, and we want to insert, let's say, I don't know, at the bottom somewhere. Let's say here, right? You want to insert like a new what we call bridge. So a bridge is basically what you know in Copper as a source and a sink, right? Like a source is where the information is coming in the system in Copper, and a sink is where the information is going out. Basically, often there is like a kind of a notion of like sensors to actuation. But we realized that not everything actually fits very well that paradigm, right? Like, and basically, when you have a system talking to a system, it's more like a mix of sources and things at the same time, and that's what we're gonna do there, right? What we're gonna use is the MSP bridge. So let's say, let's call this component flow MSP. And what we want to set up, it's exactly like a standard copper like component, right? You give it the type, and we give it the type co-bridge, co-MSP bridge. So that's the name. Actually, the thing is guessing right what it is, because it's like the same thing as what you see up there, right? We were using it for right there for VTX, right? So it's going to be very close to this, right? So MSP is like a protocol that basically this little sensor is talking with. And instead of mapping it to instead of mapping it to like the UART2, like you see up there, let's map it. So Micoair H743 is basically the hardware, right? That's like the resource that is associated with this bridge. And what we want to give that bridge is a serial port. And so the other like bridge is like UART2, but this one's gonna be on UART4. So it's gonna be simply UART. It's the same thing as there. UART4 ports, right? And that's going to be the same error, right? Like Micoair 743. My auto completion doesn't work. I'm not sure why, but that's okay. So you can enjoy me typing this as we go. All right. So that's the type. Why do we parameter that with the actual type of the port? It's because in Rust Embedded, every single piece of hardware is not only an ID and so on, but it's also like a specific type. It comes from the fact that you can imagine in one specific hardware, like that flight controller, the Micoair H743, basically everything is unique, right? Like that UART2 port or UART4 ports are actually only one. So you can actually type that, so you're sure you are not talking to the wrong port, for example, when you are actually compiling your system. And here you pass it the name of the resource, right? So it gets it right. That's UART4, and this what am I doing? Resources. So that resource basically is to tell Copper which instance of those resources in that bundle, like this Micoair H743 is a bundle. It's like several resources, right? And you need to tell it which part you want to capture for each of your tasks that needs resources. Resources could be like a serial port, like this, but it could be also, let's say, some system resources, right? For example, like a thread pool, or like for like a high-level system, or like could be some memory resources, or like a disk, or like a storage, and so on, right? That allows us to basically have copper tasks that can run not only on embedded but also on the host itself. For example, this COO MSP bridge works very well on a standard PC2, right? That's the power of those resources, right? They expose like standard traits that you can reuse in any context. All right, so we need, mapping the resources themselves, and then we need to define the channels. That's going to be the same one as those ones, right? It's the same type, so it's going to be the same channels. That declare basically the IDs that needs to be collected to other tasks in that configuration, exactly like you have for like standard things like this, right? Like you have basically those tasks have in and out, but because it's like more generic, a bridge, you have an ID per things that are tagged, knowing that they are actually transmitting or receiving through that bridge, right? And what's going to be interesting for us, this is this one, right? Basically, request responses is when your flight controller sends a request, let's say, to your goggles and the goggles answers, right? And incoming is going to be more like for our use case, where spontaneously the one peripheral on one UART, right, can send data through the channel, and that's what's going to happen. You'll see that this little lidar and flow device send us like MSP messages mapping to those changes, right, on that incoming thing. Okay, so we have that. What we want to do also is to add a sync, just to be able to log what's going on, right? So the syncs are in the task, right? In the task here, in the task list. So let's put that at the last thing, and okay, same deal. We'll define all those, right? Those ones are not done yet. So let's give it an ID. Let's say flow logger, something like that, right? And we give it a type. We'll put it in tasks in that project. Flow MSP, flow MSP logger. Okay, that's a good name. All right, and that's it. Okay, just we make it there. Put that clean. Here we go. And the last step is gonna be okay. We want to receive from this incoming channel those messages to our flow logger. So let's do that. Let's go to connections. You have a bunch now, and let's say source is our flow MSP incoming. That's actually right. This thing is smart. And the destination is going to be exactly what it says, actually, the flow logger itself. And indeed, the message is going to be to MSP bridge, where it is defined, right? And the MSP request batch. Those are incoming things, right? That could be a request, but they're actually more than requests when you think about it. All right, so we are set up. We just need now to actually code this flow logger, right? And we said that we will put it somewhere in there in in the source tasks flow MSP whatever else, for example. There we go. So we'll just import whatever is defined on our upper module, because we have a bunch there. We'll implement. So first, like we always forget, so I'll do that right away. We need to implement freezable for our. Wait. First, we need to define the structure itself. So we call that flow we said that flow MSP logger, I think. Logger, go. So yeah, for this guy. We leave the default implementation. Anyway, we don't have any state, right? So it's kind of like it's kind of stupid, right? Oh, okay. Wait, we need to attach this module, otherwise we won't have any info, like feedback into our syntax. Source bar, task mode, I think. Yeah, task mode. And let's add somewhere there. Flow MSP. Okay, let's go back to this. Okay, now it's attached. It's going to be easier. Now, let's implement a cursing task for that flow MSP logger. You see that a lot of things could be actually auto-completed, right? But we go slow, so I can explain to you step by step what needs to be done. So first you need to define a type that match our input, right? So the lifetime of the message, and that's going to be a coup MSG MSP request batch, we say, right? Go. And then now it's new. You need to basically tell the system what you want for the resources, but we don't have any, so we just put like nothing completely empty, and then you define the new. Because we don't have any resource, we can just define the new. We need to say which is. Oh. What's going on? This is going crazy. Okay. That's an option. Component config, I think. Component config. Here we go. So config that we won't use, and that's it basically. And indeed, that's going to be self. In there, oh wait, we haven't defined. Actually, it's a coup result. I think it's a coup result self. If I'm not mistaken. Then, what else do we know? That's it. Okay, self. This one is pretty straightforward. It could be like the default one, actually. Okay, one. Then we need to define the process, right? So fn process. That's going to be for lifetime I. And in there we have itself as mutable. A clock we won't use. And an input message, right, of the type self input. That's actually a reference. All right, and that's going to get us a cool result. Just to inform the framework if something went wrong when we execute this, right? So the monitoring can catch up. Let's say we could have actually copper cooling into the MSP bridge, and basically nothing happens, right? Like basically there is no new message, right? So we will have input as none. So let's let's go and say like if yeah, exactly this, right? If when we take the batch, right, it's none, right? So the batch is going to be in the input payload. Then we return just. I mean, if we don't get any new message, we don't care, right? We return just okay. And okay, and if and then we can go through all those requests, right? Requests in the batch. So there is an iterator on the batch, right? You can go through, right? And we will match the request. And if this is an MSP request, so those ones are defined in the coup MSP lib. We have a library that basically decodes MSP request. And if this is a MSP sensor optic flow, then we will just do something like very simple, like a debug. Let's say flow qual then dx. There will be like a differential in x and dy. And that's it. That's the only thing we have in the message. And there's going to be flow quality, flow motion x, flow motion y. So those are named in the message, and that's basically it, right? Then we'll do the same thing for the second one. So the second one is going to be MSP request, MSP sensor rangefinder. Range. So it's going to be the 1-point LiDAR. Yeah, we can do Debugger. Range. That's going to be in millimeter. And now, I think there is also quality equal. And we will give it range.quality. In millimeter. There we go. So that's what we're gonna do. Just gonna log the things. Oh yeah, let's not forget the base case is gonna be just do nothing, right? And once we process, okay, we go through the batch and then we return, okay? Okay, so now that we are here, let's try to compile our thing. So I have like a shortcut just that compiles the firmware. If you look at the just file again, it just does that actually. It releases with like a specific config for cargo, and just like a few things that you need to to specify like the package and which binary you want, because you can also do like the logger and so on. So just firmware, just gonna compile the firmware, and we messed up stuff. Okay, so one is all right, that is fixable. 18, I messed up. Oh yeah, there is that. And oh, interesting. Yeah, okay. The new weave is not implemented by default. So we need to pass the resources basically in new with. So where is it? CLC tasks, our flow display. Instead of new, you need the new with, and you pass it the resource as self. A whole lot of nothing. That works or not? I need to give it like a lifetime. There we go. Make it. Okay, and the last one is, oh yeah, I made a typo there. So that's line 25. And that's range finder. Okay, it built. It is erasing the flash memory in the drone. And then programming it. Okay, it starts up. Okay, it looks okay. Everything put it up, and oh wow, we have a huge spam of battery logging. So let's remove that so we can see something. That's also something I did recently. That's to see in the goggles what's your current like battery load. Charge. So let's go there and remove it because it's kind of annoying. It is. There, okay. Let's go again. All right, and let's see the distance in millimeter. You see like that's 1 meter, like 1,800 like millimeters. So that's 1 meter and a half. That's basically my ceiling. Let's put the phone in front of it. So you see 60 centimeters. Let's get closer. 40 centimeter, 43, 30, 35. We can go up 40 and so on. Okay, it works well. And then let's look at dx, dy. So if I scroll something in front of it, you see dx and dy actually going to 1, 2, minus 1, minus 5. Okay, so because it's like pretty small in the wide viewpoint, maybe if I move the sensor itself, yeah, you see minus 30 and so on. I can scroll. Oh, minus 15, minus 9. Okay, cool. So here we go. You have it. That was in a record time how to introduce a new sensor to an embedded development with copper on our new flight controller, demonstrating both the new notion of bridges. So I encourage you to look at the source code of the MSP bridge to see how it works internally if you want to develop one yourself. And also resources where you saw that we actually took the UART number 4 and used that for our own bridge. So yeah, that's almost like Lego work for embedded development at that point. Thank you so much, and see you on the next one. And feel free to join us on our Discord server. We have our link below if you have any questions.